We are taught from a young age that the Earth follows a predictable logic. Gravity pulls water toward the lowest point. Boiling temperatures require a volcanic heat source. And continents are, by definition, massive expanses of dry, solid land. But those assumptions only hold true on the surface of a standard map. In reality, the planet frequently operates through a hidden layer of complexity that creates outcomes we didn't expect. Consider this. Under specific conditions, massive coastal storms blast water straight back into the sky, moving opposite to a typical waterfall. To understand our world, we have to look past the neatly labeled maps we grew up with and investigate the specific coordinates where local conditions create these geographical anomalies. Deep in the Peruvian Amazon flows the Chennai Timpishka. This river reaches temperatures up to 200 degrees Fahrenheit, near the boiling point, hot enough to kill any animal that falls in. The immediate logical conclusion would be a nearby volcano, yet the nearest one is 400 miles away. This diagram illustrates the source of that heat. Geothermal springs originating deep in the crust push boiling water through subterranean fissures. This channels heat directly to the surface, warming the riverbed without the need for a traditional magma chamber. Look at this photo of Ireland's Atlantic coast. The sheer verticality of these cliffs creates a unique environment where the weather can overpower the expected behavior of the elements. During fierce storms, the waterfalls pouring off these edges appear to flow backward. The water is caught in an updraft and sprayed back onto the cliff tops. This happens when Atlantic storm winds exceed 100 kilometers per hour. When that air hits the vertical cliff face, it is forced upward with enough momentum to temporarily push the falling water back into the sky. From subterranean heat to 100-kilometer winds, local geography can override the environmental patterns we usually take for granted. That same unpredictability applies to our understanding of the continents. Scientists recently confirmed the existence of Zealandia, a landmass that remained unrecognized for centuries. This animation shows why Zealandia is considered the eighth continent. It is twice the size of India, yet it remained hidden because 94% of its surface area is submerged beneath the Pacific. The geologic history shows that this landmass broke away from Australia 85 million years ago. As the crust stretched and thinned, it descended below the blue depth threshold shown here, leaving only islands like New Zealand above the waves. On the surface, the Russian Federation offers a different challenge to our sense of scale. It spans 11 time zones and stretches continuously across 2 continents. To put that in perspective, look at this planetary projection. Russia covers 17 million square kilometers. That is larger than the entire surface area of the dwarf planet Pluto, which measures just 16.6 million square kilometers. Standard cartography often obscures these magnitudes, leaving whole continents and cosmic-scale landmasses hidden within our current map projections. We use time zones to organize our lives on a spinning globe, but some nations choose to ignore the physical reality of the sun's position. China spans 3.7 million square miles, which would naturally place it within 5 different geographical time zones. Instead, the entire country operates on a single legal time set in Beijing. This creates surreal patterns of daily life. In far western China, the clocks say it's morning, but the actual sunrise doesn't occur until hours after the capital has already started its day. This photo reveals a different kind of geographic complexity. Look at the small piece of land sitting inside that dark green water. This is Vulcan Point. An island in a lake, which is on an island inside yet another lake, on the island of Luzon. It is a geographical nesting doll that follows its own recursive logic. These examples show that rigid human categories, like time zones or map layers, frequently clash with the actual geometry of the terrain. The colorful maps hanging on classroom walls are only temporary snapshots. They capture a single moment of a system that is constantly in motion. This photo of Mount Everest represents a peak that is literally still rising. Because of tectonic pressure, the mountain grows 4 millimeters higher every single year, meaning it has grown over 20 centimeters since it was first conquered in 1953. In contrast, this beach in the Maldives shows a landscape that is slowly disappearing. The country's highest natural point is less than 8 feet above sea level, making it the most vulnerable nation on Earth as the oceans continue to rise. Our geography is not a finished painting. It is an active force that is continuously rewriting its own rules, regardless of what we print on a map.